All right. Well, we've concluded proportions and we're on to chi-squared. So this is 2008 question 5, and this is going to be a chi-squared goodness of fit test. And a study was conducted to determine whether moose are found in a region containing a large burned area. A map of the study area was partitioned into the following 4 habitat types. Inside the burned area is 1, not near the edge, outside, and then outside the burned area near the edge. Okay. So, and they draw a map for us. The proportion of total acreage in each of the habitats was determined for the study area using an aerial survey. Moose locations were observed and classified into one of the 4 habitat types. Results given in the table below. So we have this proportion here and this proportion there. And this number here. So I'm going to take a moment and I'm going to record this information right here into L2 and this information right here into L1. And so I'm going to pause this for a moment and then I'll come back. All right, so I've included the information. I just put the observed data in L1 and the percentage of acreage in L2. All right, so the researchers who are conducting the study expect the number of moose observed in habitat to be proportional to the amount of acreage of that type of habitat. Are the data consistent with the expectation? In other words, is it the same? The fact that they're talking about being the same or having the same proportions tells me it's either going to be homogeneity or goodness of fit. But in this case, we only have one list of observed data, only one set of observed data, or one sample. Then it must be goodness of fit because homogeneity requires more than one sample. So conduct an appropriate statistical test to support your work. So the null is the number of moose is proportional to the habitat acreage. The alternative is that it is not. And notice that every time we've done it, we've always worked with a very positive is, and here we go to is not, which is basically different. They said the conditions were met, and so we don't have to write them, but I'm going to write them as if they had not been met, and we had to check them. So if they hadn't been met, you say random sample is given. And we need to make sure that the moose population is greater than 1,770. I don't know if it is, but we're going to have to make that claim. And all expected counts are greater than 5. Well, I have to calculate those. This is where I put the data into the calculator. I just recorded it. And then I'm going to go up to the top of column L2 and go second 2. And I noticed that I had a total of 117. So if I multiply it by 117, that tells me in this section, I expect there to be, based on the acreage, about 40 moose. In this section, I expect to have 12, about 12. And in this section, I expect to have about 53 moose. All right. And so that's my expected values. I just list them in the table next to the actual observed. So what type of test are we running? Chi-squared test, goodness of fit. So chi-squared test is categories minus 1 for the degrees of freedom. So in this case, we have 4 categories. So 4 minus 1 is 3. When we show our work, and by the way, we're going to cross out this, but when we show our work, it's observed minus expected over expected. So observed minus expected over expected. And I only need to show the first and the last. All right, so how do I do this on a calculator? Stat, test, chi-squared goodness of fit. Degrees of freedom is 4 minus 1, which is 3. So I end up with a big chi-squared value and a very, very small p-value. When you have that low p-value, you're going to reject it. So the p-value is near 0, we reject the null, or the p-value is approximately 0, we reject the null. There's enough evidence that alpha equal 0.05 to suggest that the moose population is not proportional to the habitat coverage. In other words, there's plenty of evidence to suggest that the researchers are incorrect in their assumption. And then it says, relative to the proportion of total acreage, what habitat type did the moose seem to prefer? Explain. Well, that's the CNTRB. That's the contributions. But to be correct, I have to be over. So this one's under, so I don't like this. That's not good. This is over. That's good. This is over. That's good. This is under. That's good. Not good. So basically, we know it can't be this one, and we know it can't be this one. So I need to see which one of the two positives, the two that were over, had the greatest positive. Those are the ones that they like the most. Well, if I scroll across, I find that area 3 had the largest contribution. We know it was positive. So area 3 is the one they like the best. So habitat 3 is preferred by the moose. The number of moose in 2 and 3 are higher than expected. Is it 2 and 3? I did that wrong. I'm sorry, this was under and this was over. All right. So habitats 2 and 3 are higher than expected, but they prefer those two methods, but they prefer 3 the most. 1 and 4 were not considered because they had fewer moose than were expected. And what that means is we thought they were going to have about 40, but they only had 25. Here, we thought they'd only have about 12, but they had 22. Here, we thought they'd have 12, and they ended up having 30. So 2 and 3 they preferred. They didn't like 1 and 4. All right. So that concludes the one on chi-squared goodness of fit. The next one will be chi-squared test of independence.